The left part of the diagram still remains the same. But this time the code will be rather deployed on a Docker, and a system which has Docker installed in it. And then finally, we have the case scenario where it is going to be, well, a little bit more wee bit complicated. We are going to use the Ansible deployment tool, and then there will be Docker and Docker Hub, separate entities. Now, finally, the most complex one, which we are going to do, will be using Kubernetes. What is this? Day 6, day 7. Okay. So here we are going to learn to deploy code on Kubernetes. What Kubernetes is, what it can do, that is something we will cross that bridge when it comes. But once again, following the same pattern here, let me write down the major thing here. So to deploy code on Kubernetes, what we are essentially doing here is we are doing CI/CD. Initially, we will be learning this, learning how to do this manually, but then that will be your final capstone project, wherein you will be using Kubernetes to do the entire thing automated with automation. The only thing the developers will do is they are going to change the code and push it, and then it should automatically get deployed. That is the provisioning configuration of the entire infrastructure that you have to do. So the CI/CD will be, when we are dealing with Kubernetes, it will be using GitHub, your code repository, obviously Jenkins to control the integration, control, manage, orchestrate, all of it. So basically the CI server, continuous integration server. Maven to build the Java code, to create that singular web archive file. That is the only thing that machines understand. That is a machine readable machine language .war file. Then you are going to do the deployments. You are going to use Ansible as a tool. And finally, to orchestrate the entire containerization. We will learn all of this in due course. To orchestrate that entire containerization, you are going to use Kubernetes. Kubernetes is also called, in short, K8S. Okay, so it's something like this. Like in between K and S, this portion, it has got like 8 characters. So that is just abbreviated to 8. This is what your 8 is. And K and S. So if you come across K8S, it is actually referring to Kubernetes only. Okay, so what are the steps going to be here? Let's write down the steps. The steps here would be, obviously, the first step, you have to set up. So I'm writing K8S. K8S will just remember this. I'm going to, so for, I have to set up Kubernetes, but this setup of Kubernetes, this is a complex topic. There are many different ways. We are going to learn one of the most popular way, wherein we are going to use one of the services that AWS provides. It is called EKS, or Elastic Kubernetes Service. Similarly, Microsoft Azure, Google Cloud Platform, or any other cloud platform, DigitalOcean, Linode, they all have their own Kubernetes services, web services. So because our infrastructure is being built using AWS, that's why we are going to use EKS, Elastic Kubernetes. Elastic, okay, spelling error. Let's get rid of this. Elastic Kubernetes service. Okay. So first you do the setup, then there will be introduction to. Obviously, all of these topics will have their own introduction. I will always start with the introduction to the topic, core concepts, and only then I will begin using them. So here you will come up with the concept of something called pod, service. They're all components of Kubernetes, and deployment and manifest files. Actually, manifest file is one term. I don't want to confuse you. Manifest file. Okay, we will come across concepts of this. We will learn this, and then gradually we will also implement it in stages. Now, once your Kubernetes is set up and all these pod services, deployments, and manifest files are done, obviously you will have to integrate. So here you are doing the configuration actually. So first, again, the logical order of steps. First, you have to provision the infrastructure, configure it, and then integrate it. So you're going to integrate Kubernetes. This time you are going to do it with Ansible. Okay, so gradually, if you observe like the previous notes, you will see as we proceed further, we are going to offload tasks to individual machines on which you have got individual softwares deployed. So we are going to distribute the tasks, and ultimately you will see the only thing that Jenkins will be doing will be integration, continuous integration of code. All the other tasks which it was doing earlier, gradually they are getting distributed. Now here, because we are doing the deployment of code completely on Kubernetes, there will, I will draw the diagram. You will see, although we will be still creating Docker images and using Docker containers, but we will not be hosting the containers using Docker anymore. And you will realize later on, like how powerful Kubernetes as a tool actually is. So because there is Ansible, again, whenever there is Ansible, there will always be Ansible playbook. That is nothing but the code that you are going to write in YAML language. So you're going to write Ansible playbook code for two things. Creating deployments. First you will deploy, and then you will expose. This is the first one. And then the second one is the first thing that you're going to create is a deployment. And then a service. And then finally, so this is where your infrastructure has been provisioned and configured. So obviously, the last step will be your CI/CD job. Always this will be the most important part, the continuous integration and continuous deployment. So here again, you are going to use Jenkins to do what? To number one, build code. Number two, so the code will be built on Ansible because Ansible is your deployment server. You will build the code on Ansible, but you are going to deploy on Kubernetes. the built code will be sent to Ansible, obviously by Jenkins. So what will the diagram look like? Let's get into that. Okay, why is my mouse not moving? So I think I can copy the initial integration part. Code, GitHub, GitHub, Jenkins, Maven, Ansible. Actually, there will be only one change here. I can copy the entire thing, basically. Okay, did not capture the entire thing, but it will do. Let me check Ansible. Yeah. So the only thing that I need here is Kubernetes. Although this just looks like a single image that is getting replaced here. But you will see this is going to be the most complicated part actually. Let's order it backward. So once again, you're doing the same thing, but in a very different way. Conceptually also, they are very different. So we are going to, again, deploy container, but so pull image, push image, copy under. So this what is same, Docker Hub. Yeah. So basically, the main difference here between this image and this image is only that the containers are, instead of being deployed in Docker, one major shift, and this major shift is a huge thing actually. We are going to deploy it on Kubernetes. So overall, this is actually in a very summarized manner. You have, okay, not this, day 6 and day 7. These notes will be very important for you, these two sections, because here, this is where you'll have to come back to these comments and statements every time. I mean, like as you proceed, okay, because the complexity is going to incrementally increase. The complexity to do the provisioning and configuration will increase, but it will become way more simpler to maintain and to use it. Okay, so this is what you are going to go through. Okay, let's fit this and right. So now now let us the next thing that we should discuss. Any doubts, any queries related to this before I proceed? Nothing? Cool. Now, the next thing that we want to get into is, and our entire course will be guided by these documents. Okay, apart from that, anyways, I have you should have your course syllabus along with you as well. So refer to that. That has, like, whatever I've tried to explain here, our course glide path, it is based on that same thing. And they are in order, incremental order. Now, the next thing that we should know about is CICD. What is actually CICD? Okay, so you have already come across this term, like there is CI and there is, so CI stands for continuous integration. Continuous. Now here, but compared to that, CD is not a single thing. CD can mean two different things. CD actually stands for, so CONT is continuous. The first option is delivery, and they are different things. You must know this. And the second option is continuous deployment. Okay, so CD is not the, and continuous delivery and continuous deployment are not the same things. They are different things. They have different meanings. Continuous integration is where everything is getting integrated automatically. Okay, so for example, like I actually have to pull the image. No, this is Docker. Which one am I want? I'm looking for this one. Yeah, give me a second. Let me grab this image so that I can show this thing. Let's see. So what is the difference between continuous delivery and continuous deployment? In the software development lifecycle for any project, when code is what the changes are that need to be made to the software, they are gathered during the requirement phase and frozen. Once they are frozen, and all the stakeholders like the customer, the solution expert, the develop lead, or maybe the lead from the development team, the business analyst, project manager, all these stakeholders in the project, when they give their sign off, then the document is frozen. That is called a business requirement document. The entire project, whatever, that is sort of a legal document wherein the scope of the project is defined, what all tasks, what are the objectives of the project, what are the deliverables for the vendor towards the customer, what things are out of scope. Once that document is frozen, whatever version, it actually keeps getting versioned. It keeps like every project has got iterations. Okay, iteration 1, iteration 2, and then it keeps proceeding. Once you create a project, it is so during the first time, that will be only once you're creating the software. But once you have created it, you need to maintain it. You need to maintain databases. You need to maintain servers. Even if you're not making any enhancements, there you will always need to maintain. Just like you buy the car only once, but after that year long, you have to keep maintaining it. You have to take it to the service center, check its oil, check its air conditioning and stuff like that. So similarly, a software also needs to be maintained. Its configurations, its basically you have to keep doing the health status check. Later on, you will realize that when you use Kubernetes, how much we can automate this. In it, rather we can automate it in its entirety. Okay, so we will just need to monitor its health status. That's all. So similarly, in any software project, these are it goes. That is why it is called a software development life cycle. Although you are not going to develop even if you are not going to develop an existing software, you are definitely going to have to maintain it. So initially, a software project, it starts as a when you are building the software project, it is like the main intention is there to create the software. But after that, it becomes a support project wherein you have got support teams. Like you might come across, like for example, you are using some premium version of some software. Okay, then for me, I'm using the premium version of Microsoft Office here, Microsoft 365. Okay, so in case I come across any trouble with the software, then I will call the customer care. So that customer care, this is going to be a technical customer care where they will have levels, level 1, level 2, level 3 of support. So basically what they are doing is they are maintaining an existing software. Like, for example, I'm using this OneNote, Microsoft OneNote software here for collaboration. It's a collaboration tool. You can consider this to be a kind of a DevOps tool, actually. So if the customer faces any issues, then they are going to maintain it by providing service. So that is so when you are going to write code, you can do only two things. Either you are going to create something new in the software, or the second option will be to maintain something for an existing software. In either scenario, you will require continuous integration and continuous delivery. Okay, so which part is going to be continuous integration? Let's actually see it in the diagram. There you go. So till the Maven part here, let me box it. How do I box it? Do I need a different color? Okay, maybe I can add a pen. Let's choose orange. Taken up. So your integration part here is going to be GitHub, Git, Jenkins, and Maven, only this part. So whatever is in this box here, this orange box, okay. Actually, this includes this war file also, but I think I will leave it up to here. This war file is also part of this, okay. It is green color, so just understand it. This part, this entire thing within the orange box, this is your continuous, this is your CI part, okay. CI, I'm just writing continuous integration. Now, let me go back to continuous delivery versus continuous deployment. I gave you that idea about build projects and support projects, okay. In either scenario, you need CI/CD, but then this CD is continuous delivery and versus continuous deployment. Here you have to understand the difference. When you have, so either way, like be it a project where you are creating new software or you are supporting an existing software maintenance project, in either scenario, it will go through a change and release management process. Okay, if you want to learn all of this, these are topics related to project management. The project will be run according to a certain methodology. Waterfall being the oldest one, but then we are in DevOps. So if you do not know these, then you will need to be aware of terms like agile. Just like so agile methodology is a method how you are going to implement a project, the protocols, the rules, the conditions, how the team is going to interact, and how are you going to proceed with the day-to-day activities, in what order, in what manner, what are the tools you are going to use. So in modern day software engineering, agile happens to be one of the most popular one. Similar to agile, DevOps also has got its own methodology, but then the DevOps methodology for handling a project, 70 to 80% of it has actually inherited from agile methodology. So you will find lots of similarities in the manner when you manage a project, comparing agile methodology or DevOps. Now, in the project, it will go through that entire life cycle, build the code, I mean, like write the code, push the code, commit code, build it, and then deploy. Now, during these stages, because see, you are going to change the code. You're going to change the environment where the code is getting deployed. So you are directly going to affect the users. In the project, when you are going to do that, when you are directly going to affect the customers, you can either implement continuous delivery or continuous deployment, not both, any one of them. So the only major difference here is in continuous deployment, usually continuous deployment is done where the team is very mature and experienced. They have got years of experience, and then they know what they are doing. There are no surprises, and it has sort of become a routine tasks, repetitive routine tasks. In those kind of scenarios, you are going to implement continuous deployment method. But if there is a situation where you are going to make changes that is going to affect customer, then it does require a series of approvals. Okay, there will be a change manager, there will be a release manager, there will be the project manager, there will be the customer. So it has to go through a series of approvals before, because during integration, what is going to happen is multiple junior developers are going to write their own code. Okay, multiple developers are going to push code into GitHub. All that code, once it gets integrated, and I mean, like that is going to be built by Jenkins and all that. But in your development and testing environment, are they working properly? If the code is, so you have to test it in the testing environment first, and then after that get the result. So here in continuous delivery, it is becoming a little bit manual. The code is not automatically being deployed. The reason being, every time you're changing the environment, you're pushing the code into the actual environment where customers are going to use it. There is going to be a review process where the major stakeholders, these are usually senior management, technical and non-technical, both. These are not going to be individual people. Sorry, they are going to be like individual, not the entire team, but the heads of each, like the test manager. There will be a test manager from the testing team, overall, whose sign-off will be required. Yeah, our testing is done. We have not found any more bugs. So this code can be pushed from the staging environment into the production environment. So if the test manager gives a sign-off, then one of the stakeholders, major stakeholders is agreeing that this code is good. We can push it into production, because production is the lifeline for the customer. If production is down, customer will not be able to earn his bread and butter. So production can never be down. For example, when I say production, you all do online banking. So whatever bank you are subscribed with, your patrons of, the banking website should always remain up. That can be, maybe you might need it at 2 a.m. if you're traveling, or maybe you need it during the daytime, of course. But the website should be up. And the website from where the environment from where you are pulling the banking pages, that is called production. The live environment, which users are interacting with in real time. So in continuous delivery, there is always this human intervention where one by one, the stakeholders will approve. And finally, it is going through, once they approve, only then the code will be deployed. That is called continuous delivery. But whereas in continuous deployment, we will not require any approval. Like over a period of time, the team has matured enough. Everybody knows what they are doing. There are fallbacks, rollbacks in place. In case things go wrong, then you can immediately switch over within a couple of seconds. That process where you are going to do it like without human approval, like the only thing that is going to happen is in GitHub, new code is going to be injected. Automatically, the result of that code, which is nothing but changes in the website or web application, will automatically get deployed. Nobody needs to do anything. Only the development team a single or multiple developers. Usually it is a multiple developers are involved. They are just going to push their code. That's it. That is called continuous deployment. So in our method here, because we are dealing with a simple website, we are going to use continuous deployment. Continuous delivery is something that is a little bit advanced. In GitHub, you will have pull requests. You have to manage that. You have to allow, invite stakeholders, and then you'll have to review the code. And then, so usually in continuous delivery, you are going to deal with multiple developers. This is not a one-man operation here. Okay. And this is something, continuous delivery is something that you will get. So usually from development to testing, testing to staging, these environment changes when the code is getting moved from one environment to another internally. Whenever the company is working internally, they are usually continuous deployment after a certain 1 or 2, 3 cycles, when people get habituated with the tasks and the system is in place. During that time, it is continuous deployment. But then, this is the real-time scenario I'm saying. But then when from the staging to production, which is going to be real-time, affecting customers real-time, as long as you are working internally, that everybody is part of the project development team, the testing team, operations team, as long as they are working internally, that means your development environment, testing environment, and staging environment, as long as you are working in these 3 environments, it is fine. You are not immediately affecting the customer, but you are going to affect the customer. You will be going to affect the customer once your code is finalized. That is in the staging environment. From staging, you are going to push it into production. During that time, you will implement continuous delivery, wherein there will be human intervention. It will, the code, the process, release, everything will be reviewed by senior technical management mostly. Non-technical means the customer. They give their sign-off. And then finally, you give the go-ahead to deploy the code. So that is how CD actually works. In our course, we are going to implement continuous deployment. That is the big difference between continuous delivery and deployment. Okay. For realizing continuous delivery, you actually have to work real time with multiple teams, multiple resources, multiple environments. All of this cannot be showcased to that extent in a demonstration environment. Okay. But anyways, you should know it. So this part is your continuous. This is your CD. However you implement it, with delivery or maybe through deployment. Now, before I proceed, do we have any clarification? Anybody has any questions or doubts? Nothing? Good. So remember, CD can mean 2 different things: continuous delivery and continuous deployment. We are not going to, as part of this project, we are not going to focus on continuous delivery. We are rather going to do continuous deployment. So now, what are the resources that you will need? Let's get into that. So obviously, you are going to require a AWS account. Without that, nothing is going to happen. So I hope by now you have created your AWS account. I think I've already shown you how to log in as I create. What? Okay. Does come up with admin. Really? Let me do this afresh. I hope I have not messed up the password here. Yeah, this is IAM account. So yeah, okay, this should work. I don't know why it is not working. Yeah, there you go. Maybe a previous stale cookie session. I think I should sign out every time. So what are the resources you are going to need? Actually, I don't need to write this. I'm going to show it anyways. Now, earlier, it seems mobile XTEM is installed. So I've already, most probably in all probability, I've shown you how to log in. So you're going to need a AWS account, log in as a IAM admin user. And then we are going to, for the remaining part of the course, we are going to use mobile XTEM explicitly, okay, to connect to your account. And what? Oh no, I think I should rather write it down so that you can refer to this. There are multiple things, even I will forget. So this required. So the resources required one by one. Let us enumerate it. So number one, we will start with AWS free tier account. Number two, you are going to need mobile XTEM. Okay, this is going to be the tool for connecting to the remote server. And next, you are going to require, let me actually write it down first, and then one by one, I will show you how you are going to have to install it. Obviously, you will require Git client. And then you are going to require, if you are using Git client, obviously you will need a GitHub account. Git and GitHub are different things, okay? They are not the same thing. Git is the actual software. GitHub is just a platform where it is where they are providing you the repository features so that you can, it's a platform which you can use to store your code and share your code. Okay, understand this thing very clearly. Without Git, there is no GitHub. Okay, for example, okay, somebody is asking, are the recording links available in future? No, there is nothing available offline. You will have to stay connected to the internet because the recordings will be present in Google Classroom. So you will definitely need internet access because it is going to use Google Classroom. That is a cloud service. Without internet, it will not work. Right. So we are going to need GitHub. GitHub is that platform. Git is the local client that you will install. And what else? What else? Yeah, basically, I can think of only these things right now. And apart from that, obviously, the softwares, as and when we proceed, we will keep installing. So AWS and mobile XTEM, till this part is done. These two are done. Git client. Okay, so let us install Git client, or it is also called Git bash. So go to your system, do a Google search for Git. Okay, go to this link, gitscm.com, git-scm.com. This is the main website. And download it for your, like it is available for Linux, Mac, all of them, okay? Windows. So just download this. Actually, let me do one thing. This is the page that you need to go to. So for the Git client, this is going to be your link. And let us download it for Windows. Now you will get various options depending on the system architecture. This is not on cloud. This is going to be on your local system. So we are going to use, I have got a Windows setup, which is for 64-bit, okay? And I'm taking the installer version rather than the portable version. In portable version, you will have a single exe file. So configuration changes will not be possible there. So let me download this 64-bit Git client. There you go. Let's go to the downloads folder. Okay, it's thinking about it. So this is what it will look like. Right. So let me double left click on it and install it. Windows Firewall will obviously block it once. Well, something is happening. Yeah. I was expecting this. Just click on yes. Accept. Next, just do one thing. Additional, check this box on the desktop also. It is better to keep the icon, and rest of it is just same. We are going to use the Vim editor. You will learn what is Vim. Don't change anything here, okay? Otherwise, it will have downstream consequences. Gate from command line third party, so that's fine. So open bundle, yeah, this is also fine. Open SSL library, fine. NTTY, yeah, that is fine. Default. So let's choose all the default settings. Enable system caching, fine. Leave this unchecked and install it. So the benefit of using, so this is called Git Bash. This is the software. This is the official software. So Bash refers to born again shell. That is a Linux thing. The unique feature of this is that using Git Bash, you can, so for writing code, editing code, and then pushing code, all of that you have to use pushing the code, you have to use the Git client. So Git Bash actually is installing this Git client software now. Okay, so that same Git software is also going to be present in the next thing that we are going to do is we are going to register our account with GitHub. That is another resource that you will definitely require. That is going to be your central repository where you are going to store the code and also share the code. In both the scenarios, it will not work without Git. And using Git Bash will enable you to be able to use fire Linux commands in a Windows environment. That is its unique feature, because you are going to have to type Linux commands. So I don't want to view the release notes. And yeah, let's click on finish. And if you click on Git Bash, this is what it will look like. Okay. So so I can actually type Linux commands here, like pwd, present working directory. Now, there is one major difference between Windows and Linux. This is Linux style. Okay. The files and folders, they are always using this \. But if I do this same thing in Windows, for example, if I open the command prompt, okay. So this one here is Git Bash, and this one is Windows command prompt. Okay, can I maximize it? See the difference here. So I don't need to type pwd. If you see the directory structure, here they are using / in Windows. But in Linux, it is always \. Okay, and this one major difference will make it very difficult for you to type the lengthy path folder, because the folder path you will always have to give. Okay, so that is the reason why so this is one major difference. Otherwise, you will keep getting error because of the /. So the very easy way around this is, you don't have to type cd, change directory, and then see, that is the problem here. If I want to go to the downloads directory, now, actually it is not showing the path, somewhere I need to configure it. But if I right click on this and select properties, So see, this is its path. C users admin downloads. Okay, so actually, if I do LL, whoops, too much. Okay, it is also showing all the details here. Control L, clear the screen. LS. Okay, it is still showing lots of details here. So I want to try go to this, navigate to this downloads folder. Okay. So this is how you will have to navigate. If I do a PWD now my path is different. Okay. Because you need to be in the correct project folder. Otherwise, you will not be able to do Git. You'll not be able to fire Git commands. Now, navigating to these folders, because although you are using Git bash, and here in this Git bash terminal, you are typing in Linux commands, your operating system platform is still Windows. And whenever it is Windows as its own structure. So you're always going to come across this problem. Now, for example, like this is the downloads folder. Okay. Now, maybe on the desktop, I'm creating a folder, my project. Projects, enter. Now I want to, this is where I will keep all my projects. Okay. So maybe let me just create one. So maybe like this is project 1. Control C, Control V. And this is project 2. So different projects will have different code bases, right? It starts with the developer's machine. So now here I'm doing the role play of a developer. So project 1 will have its own code, project 2 will have its own code. In both the cases, you will still need Git to push your code. And then you are going to use Git bash. Okay, so navigating here from folder to folder, because you are not in a actual Linux system, is very difficult. Because when I mean, like, even if I copy the path from here, like go to properties and see, this is the entire path. Even if you copy it, it is very irritating. So I'm using Control C here, and let me go back to Git bash, do a Control L, that will clear the screen. And if I type CD, change directory, and type the path, okay, that I want to go to this path, it will not work. It will fail. The problem is, it is just because of this bash. These are Windows. This is designed for a Windows structure, Windows operating system. Okay. So you will need to travel between various folders. So a very easy way out is, instead of typing, copy pasting the path or searching for it manually, let's just simply close this. If you are working on project 1, open it in Windows with mouse click, and then right click and open Git bash here. Use this option. Okay. Because you are going to need it. And then automatically it will open it up in project 1 folder. And then you can, so if you do your PWD, see, now it is giving it everything in the Linux style. Root, C, users, admin1, desktop, my project, project 1. This is how you are going to use Git bash. So yeah, let's go back, but we are not learning Git right now. I sort of digressed. Apologies. Let us create our resources. Yeah. Let us keep this exactly in the center. I don't know why I did that, but what is the next thing? It's already 16. GitHub, right? Let's create a GitHub account. So by installing Git bash, you have installed Git client locally in your system. Without that, you cannot do version control. But we need a remote repository. Okay. So we are going to use a free GitHub account. And for that, you are going to need your email. Let's see. I'll show you the process here. I'm also going to create a fresh GitHub account so that I already have multiple accounts, but I want to show you because you are learning from the beginning here. So their website is pretty cool actually. So here, let us actually in this page, it's already present. Go to this website and do the required sign up. So you will need an email address. That is the reason why I told you before joining at the beginning of the project, create a email only for this project because there will be multiple logins, multiple resources that you will need. So let me fetch my email. Really, can I copy this? Yeah, I can. So this email I have specifically created for this project, this course here. Okay, so this email. So let's click on sign up for GitHub. Pretty easy and straightforward actually, but nevertheless, you will require this. The way they have built this looks as if some kind of gaming website. It's actually doing something. I'm waiting for it to load. There you go. Enter your email. Already entered. Click on continue. Create a password. Let it suggest some password. And click on continue. Okay, is it doing something? Yeah. Okay, it was checking the password. Fine. Enter a username. Okay. Can I use B71? I'll just put in B71 for I've got many IDs. What's happening? Why is it so slow? CPU usage 100%. Okay, there are lots of cookies are working in the background here. B71 DevOps. Continue. Would you like to receive? Let's just type no. I don't want any advertisements. So GitHub is actually originally it was its own company, but later on Microsoft actually procured it. Verify your account. So green tick, create account. Excuse me. Let's begin there. Unable to verify your captcha response. Something was loading or what? Why would you do that? So I think some captcha was supposed to load. Or maybe I'll check my email. Have I received anything? How do I verify? They actually keep changing their GUI, so can't help it. vCenter DevOps is available. Type Y for yes. And for no. I think there should be a captcha challenge that should come up now. Yeah. Please solve this puzzle so that we know you are a real person. Of course, I'm real. Use the arrows to rotate the animal to face in the direction of the hand. Okay, fine. Kitty cat, place it here. Submit. One done. Okay, another one is coming up. Make sure the animal is facing in the same direction that the hand is pointing towards. Okay. All right, I made a mistake. I actually pointed towards the fingers. So try again. There. Submit. Come on, I did 2. Okay. Submit. So your images will be different. I think I just have to wait without clicking on anything. It is processing. And then click on create account. So now you are in the please verify your email address. You are going to get a code in your email. Go back to your email and get your launch code for GitHub. I'm going to be lazy and simply copy it and paste as plain text. And it will do it automatically. So now you are welcome to your GitHub account. It's still loading. How many team members? Just me, because are you a student? Always choose student, because you will have free features, but then this is actually something which is it's a paid software. But then we are going to use it in the free form. We are going to have public repositories. Collaborative coding. So let's check this. It's nothing but just choose these 2 options. They are fetching data. So obviously I'm not going to go for the GitHub Pro. I'm going to go for the free version here. So you have got certain limits, but this will be good enough for us. They are giving you 500 MB of package storage. Code spaces we are not going to use. That is advanced thing. So the CI/CD part we are going to use. 2000 per month will be allowed. So continue for free. Create your free tier GitHub account. There you go. Make sure to remember to bookmark your account. Tomorrow I will show you how to do this, how to use it. So I have my GitHub account. This is how you create your GitHub account. You are going to need this account. And then we are going to create repositories and code and all that. That is a Git class that we will do tomorrow. So do we have any questions? Let's unmute ourselves and ask any any doubt clarification you need. This is the time to ask. So we have successfully done all of these. All these 4 resources, and anything else that will come up, we will do it real time. There will be lots of installations we will do, but they will be, if it is on the cloud, we don't need to bother about it right now. It will not be in your local system. So my system is now ready. The next thing that I need to give you is the code. That code base I will share. I will show you how you have to. You have to actually learn Git for that. So that will be in the next session. Any questions? Or else I will wrap up the session. Nothing? We're good?
Hello.
Yeah.
Okay, so so the Git part, it's like it's kind of development part, which is we are just learning purpose, we are doing it, right?
No, not only development. You as a DevOps engineer will also need to fetch the code. Go back to the diagram. That is the reason why, although it was a little bit boring, I know. But so, for example, when you're going to deploy code on Kubernetes, you will need Jenkins to pull the code. Where are you going to pull the code from? From GitHub. So this is your configuration part. You're going to do the configuration here. You will need access to the GitHub account. So it is not only developers.
So only thing I need to know from Git to just how to pull it, right?
Basics of Git command, I will know. Git overall, how it works, what it does. The basics of Git you will need to learn. But as far as our project implementation is concerned, now see, now in real time, you are going to make changes also, right? You are going to do the role play of developer. We don't have any developers here. You are the developer during the training phase.
Yeah.
So if you have, so how will you push the code? You have to learn the basic Git commands, right?
Yes.
So Git is something that I am going to teach you.
No, for real world, I would say that, okay, I wouldn't do anything. I will just only pull the code. I'm not going to touch anything to the code.
But you might add files. No. It is not always with code. There are helping files also. You will see that. Like YAML files you will need to push. You are going to write configuration files, right? Although the developers will not be using that. But for your deployment and configuration, you will need that for your integration. You will need those files. How are you going to tell? So you're going to write some code in Ansible. That code needs to be available in GitHub, because Jenkins is going to pull it from GitHub.
Got it. Right?
Okay. And apart from that, there should be one true source during the project so that everybody is able to view. You're not going to work in silos here. All the files will be readable, at least, if not executable or writable, but at least readable to the other team members so that they can check what is going on in the background here. All right. And suppose you keep your code locally in your system crashes, then what? The project, you cannot, the project cannot collapse, right?
Yes.
So it is in a remote repository. So see, GitHub is not maintained by us, but we have created the account. In work environment, you are going to have a pro account. Okay, there will be several levels of approval because this is going to incur expenses in dollar. So there will be an expense. There will be so there is something called CapEx and OpEx, capital expenses and operational expenses. So once you purchase it, that is going to become initially when you purchase it, it is going to be a capital expense. That is the expenditure for the infrastructure. But after that, if you have to maintain it, that is going to be operational expense. So that will go through some higher level of management who is authorized to do that spending. Okay, because you're not going to use your personal credit card or debit card for procuring the account, or like if there is a monthly bill that is going to accrue, then that has to be through an organizational. There should be some financial instrument, right, which the organization is approving. That cannot be a employees or contract workers personal card or financial instrument. So yeah, I hope that answers your question.
Yeah, and one more thing. Are you going to cover like GitHub desktop application, how to use it?
No. That is unnecessarily complicating things. If you can open it in a browser, why do you need that desktop thing? Don't make your system heavy. The browser will be good enough for us. We are not going to push. So we will learn how to push code from GitHub. That is going to be the easiest way. We are not learning development here. That is why we installed Git Bash. So that so developers will always first work on their local systems, right? Then that local code, your local repository, how you are going to make it available, unless it is there in your public repository. Okay, that is part of Git class. I will be covering that in Git. Overall. Okay, so there you will learn. I have to give you the code base. Then you will learn how to clone it, how you to push it, how you to make changes from your local repository to your GitHub repository, the remote repository. So, I mean, like the browser is good enough. The desktop version is nothing, but it is just a desktop version. Okay. Either way, I have used multiple tools, and believe me, using Git Bash for making, from the developer's perspective, making changes, code changes through Git Bash is the easiest method. It is practically the easiest method. Okay, so no, we are not going to use GitHub desktop and all that. So don't digress from the actual topic. It is something that is just an add-on feature. You don't need that really. The browser is good enough. All the features in browser are good enough for us to work with.
Okay,
Cool.
great. Yeah, thanks. Yeah.
Right. Anything else, or else I'll have to. I'll actually have to jump into another meeting. The next thing we are going to then learn tomorrow is going to be Git. Now let me check. We are done with the resources. Yeah, so basically I have to show you how to use the source code. Source code I will provide you. It is going to be on a public repository so that anybody can pull it. I'll teach you all of that. Right. On that note, let's wrap up today's session. I hope you learned something from out of it. Go through the recording. There are multiple concepts here. Do not try to replicate my steps during the session. Otherwise, you will miss out on the understanding, conceptual understandings. So keep these resources ready. You will need to implement this. You need these things installed. So I've already shown it. That is why I am using a operating system from scratch here. So only the required things are there. That's it for today then. Take care, guys.